Hi, you're welcome to Genius Ideas. In this video, we'll be using OpenCV and Haar Cascade to detect vehicles in images or videos. Haar Cascade helps us to find objects, and we can even make our own custom cascades for different type of objects. So this project has a wide range of applications beyond just vehicle detection. You can also do for face detection and maybe to detect animals, pedestrians, and all that. But today we just focus on car detection. So we are going to be using a Python library called OpenCV. So the first thing you want to do is to install the package in your device. So for you to install the package in your device, you can open your terminal and run install pip install OpenCV hyphen Python. So, but since I'm running this inside a kernel, I have to add this to let Python know that it's a terminal command. So I've installed this on my device initially. That's why it's giving me this requirement already satisfied. I think it's around 6 MB or so. The next thing you want to do is to import the necessary libraries we are going to be using in the program. So the first library is the PO library. From PO, you import the image class. Also, we are going to be needing CV2. CV2 is coming from OpenCV Python. Then we are going to be needing NumPy. We're also going to be needing request, but request is not necessary if the image and the video is on your device. For example, the image and the videos I'm going to be using in this project are here already. They are here, the cars and the images. But for if yours is hosted on the internet, you can simply use requests to you add the URL and it will download the image or the video to your to it will bring it will make it available in the program that you're working with basically. So but I'm not going to be using this, so I can just comment it out. So after importing the libraries, the next thing I want to do is to open the image that I want to classify. So I can say img equal to image. The image is coming from pew image dot open. Then I will pass in the path to the image. So since the image is in the same folder as this one over here, I'm going to be using this highway.png image over here. So I can just say highway.png, and that does it. But to make the image more readable, because the image might be bigger than my screen and all that, so I would just want to bring it down to a particular size that it will be easier for me to work with. So I can do something like img equal to img the resize. I can call the resize method. I'll pass in a tuple, say 450 by 250. So this is going to resize the image for me. So if I want to show the image that I'm working with, I can just say img, run it. You can see this is the image over here. This is the image over here. This in this image we are going to be doing all the classifications that we want to do. Like we are going to be detecting all the cars in the image. So mind you, the program is not 100% efficient, but it has a high degree of accuracy depending on the lighting, the camera angle, and so many other factors. So the next thing we want to do is to convert this particular image to numbers, because a computer will not understand this image directly, but a computer understands numbers. So for us to convert this image to numbers, we are going to be using the NP array, we are going to be passing this image to a numpy array, and the array will automatically generate the number equivalent of this image over here. So how do you do that? You would say, you can say img array, okay, equal to np dot array. Then you pass in this image that you have over here, img. So if I want to display img array, guess what? You can see this is the array equivalent, the number equivalent of this picture over here. So this is what I'm going to be working with, because like I said, the computer won't understand this picture directly. You need to convert it to numbers. Numbers is what the computer understands. So moving on, to get better output and to make it easier for this program to detect those cars, we need to convert this image to grayscale. We need to convert this image to grayscale. How do we do that? So we can say img gray equal to, you can say cv2 dot cvt color. Then you pass in this image array. You pass in this image array over here. Don't forget, we are trying to convert it to grayscale. Then what kind of color? cv2 dot color underscore bgr to gray. Okay, it should be two. Okay, so this line of code over here is going to convert the the image to grayscale. So after converting the image to grayscale, for us to see what this looks like after converting it to grayscale, we are going to be using this image class again. We are going to be using the image class again. How do we do that? We say image dot from array img underscore gray. You can see this image over here, I've converted it to grayscale. This image over here, I've converted it to grayscale. So now after converting the image to grayscale, the next thing I want to do is to remove all the noise from this particular picture. Now you can see the image. I don't want to see all this, even the road. I don't think I'm interested in the road. So for me to remove the noise, it means that I will kind of downgrade the image to some extent, in such a way that only my object of interest will stand out. So that is what I want to do, to ensure that only my object of interest stands out. So how do I do that? Basically to denoise the image. So I'm going to be using the Gaussian blur to remove the all the noises in the image. Basically, let's do it. So for us to do that, we can say the image blur. The image blur will be equal to cv2 dot Gaussian blur, Gaussian blur. Then I'll bring in my gray image. After bringing in the gray image, I can pass in a tuple, say 5 by 5, then 0. So this line of code basically is going to denoise the image. So for me to see what it looks like now, image dot from array, then img blur. Run this. You can see what I have over here now. You can see all the cars are the only things standing out on this image over here. Let me give you an example of a noise. You can see this thing I have over here now. You can see this signboard over here, this sign over here. If you come here, the sign is barely noticeable in this particular one. So that is what I'm trying to achieve. If I convert this to numbers now, it will be easier to detect the cars in this image. So I also have to dilate the image. I have to dilate the image. For me to dilate the image, to make it to maximize efficiency, so I can say img dilated equal to say cv2 dot dilate. Then I bring in my blood image. And after bringing in the blood image, I'll say maybe np dot once, and I'll pass in a tuple, say 3 by 3 by 3. And for me to see what the dilated image looks like, I can say image dot from array, image dot from array, then img dilated. Run this. You can see what the dilated image looks like now. You can see what the dilated image looks like now. Now, after dilating the image, one more thing that we have to do to in the image processing part is to perform a morphology transformation with kernel. So basically, we want to find the difference between the dilation and the erosion of the image. All these are supposed to add to the efficiency of the classification that we are going of the cascade algorithm. So the next thing we are going to be doing is to create a kernel. So we can create the kernel. We say this kernel will be equal to cv2 dot get structuring element. Get structuring element. You pass in cv2 dot morph underscore ellipse. Then you bring in a tuple, say 2 by 2 or so. Okay, now that we've created the kernel, now we can say the final image will be equal to cv2 dot morphology x. You bring in this dilated image. Now this dilated image, you pass in say cv2 dot morph underscore close. Then you bring in this kernel that was created over here. Now with all that, let's see what our final image looks like. Image dot array from array final image. Now this is what the final image looks like. This is what we are going to be classifying. Basically, this is what the final image will look like. So you can see the processing that we have done on the image. This is the original image, but we have processed to this point, processed, and we have processed. Now we are ready to make classification that is as accurate as possible. Now the first thing you want to do is to bring in the let me say the sample cast that we have already, because the cascade algorithm works in such a way that you feed data to the machine. It will know what a car looks like, so that it will be able to detect that, okay, this is a car, this is a car, this is a car. You feed in a lot of cars to the machine. Then after feeding a lot of cars to the cascade, it will you now use the cascade to detect the cars. So we can see this XML file over here, cars.xml. So I've downloaded it already. You will see it in the description below. This cars.xml consists of various kind of cars that have they fed into the this XML file already. So we are going to be using it as our base file. So you can say the cascade source equal to cars.xml. Yes. Now after doing that, the next thing you want to do is to create your cascade. You create your cascade. You can say car cascade equal to cv2 dot cascade classifier. Then you bring in the classifier file. That will automatically create the cascade. Now after creating the cascade, the next thing you want to do is to say the cars coming out of this cascade over here now equal to this car cascade dot detect multiscaling. Then now this multi-scale that you want to detect, you're going to be detecting using this final image over here. This is the line of code that is detecting the vehicles. So you can say 1.1 comma 1. So the reason why you have to add all these ones is so that it can detect any size of cars. You can see that the cars closer to the camera is bigger in size compared to the cars far away from the camera. So now moving on, at this point now the cars have been detected. If I say cars, you can see all these numbers over here. Now these are the cars detected. So the number of cars that he has detected, I can just say the length of cars. You can see, yeah, he detected 21 cars, and the cars in this picture, it's obviously more than 21. And the accuracy, a lot of things can affect it, like lighting, the camera angle, even your computer's processing speed too. So now the next thing we want to do now is to draw a rectangle around each car that was detected. To draw a rectangle around each car that was detected. So how do we do that? We can say for we can do tuple unpacking. Say xy, the width and the height. In the cast that was detected, what do I want you to do? You draw a rectangle, cv2 dot rectangle. Now the rectangle will be drawn around, so it will be drawn around this image array over here. Now the beginning point will be x comma y. So we're also going to be having x plus the width, then y plus the height, and the color is going to be red, so that is going to be 255. That is the RBG code of red. then the thickness of the rectangle is going to be 2. So that is it basically. Now, to display the image from array, image, no, img array, you can see the 21 cars that were detected. One, two, even this one that was closest. So one, two, three. You can see all the cars that were detected. You can see we have 21 of them that were detected. So it wasn't. It couldn't detect one, two, three, a bunch of cars over here. This one, and this other two over here. It couldn't detect it. So basically, that is how you detect a car in an image. So I have a couple of other images that we are going to be using to test. So basically, I would like to copy everything to one spot. So if I just change the img, it will reflect all around. So this is the grayscale.jpg. Okay, so this is cast underscore one.jpg. So you can see how he classified the cast. So you can see the lighting for this one. The lighting for all the images is different. He classified a lot of cars that are closer to the camera for this particular image. So you can see that the accuracy varies depending on the lighting condition, especially the lighting condition of the camera. So basically that is it for images. Now you just have to tweak this code a bit for you to be able to classify the cars and videos. And basically, one thing you will know is that a video is a collection of. You can refer to a video as a collection of pictures that are played very like for some videos you can have like 15 60 frames. You can have 15 frames per and all that. So it's just you can refer to a video as a collection of pictures that is played at a very fast pace. So all you have to do to convert for you to be able to detect cars in videos. I have some videos over here that we're going to be trying it with. So for videos, all you have to do is to bring in the source of your video. That's the first thing you want to do. You bring in the source of your video. Let's say video source. So equal to what video are we going to be using? Let's say cast.mp4. Let's use cast.mp4. So cast.mp4. So now that we have our cast.mp4, this is going to be the video that we're going to be using for the classification. So you come and read the video basically. So you can say the capture will be equal to cv2 dot video capture. Then you bring in the video source. Now after bringing in the video source, the next thing you want to do is to start a while loop. The while loop is what is going to be displaying the video basically. So while true, now like I said, a video is a collection of frames of pictures basically. So I'm going to be doing a tuple unpacking over here. I'm going to be doing something like the return and the frame itself equal to capture dot read. So it's going to be reading each of the picture frames. So we can bring in everything that we did here. Can bring in everything that we did here. We're going to be starting with the grayscale. So image gray cv2.cvt color image array. So but for this image array over here now, what we are going to be having is frames instead of image array. So this is going to be frame. So don't forget that what we have here is image array. First of all, we bring in the image, we resize it, then we convert it to an array. But in the case of the video now, this frame that is going to be returned is going to be returning the array itself. So we just pass the array into all this. So after drawing the rectangle, the next thing we want to do is we want to display the frame in a particular window. So how do we display the frame that way? We can say cv2 dot the image show, and we want to show it in form of a video, and the video that we want to show is frame. Now we have to put a catch over here. So we can say if cv2 dot the weight key 33 equal to 27, we can say break out of the while loop. So basically what this line is doing is telling the computer that as soon as I press, if the video is running now, as soon as I press escape, it's going to close the window and terminate the loop basically. So now anything that will make the program break out of the while loop, I want to destroy every window that is associated with cv2 for safety reasons. So cv2 dot destroy all windows, open and close. Okay, so the first video that we're going to be reading is cast.mp4. Let me come back here. You see this cast.mp4 over here, that's the one we're going to be capturing first. So if I should run this, you can see the cast over here. It is not putting the frames on the cast. What is wrong? Okay, it is supposed to be, it's supposed to be drawing the rectangle on the frames. I'm drawing it on the image array. So supposed to be drawing it on the frames. So if I should run this again, no, that would be frame rather. Okay, you can see what it's doing now. It is detecting the image. It's detecting the, actually it's a blue line. This is supposed to be 00225. This is blue. Red is going to be 255. Okay, I want it to be a red line. Come back here. Okay, you can see it is detecting the can see, I don't know, it is detecting this one as a car as well, but that's not correct. So this car over here, okay, you can see it is detecting it now. So that is how you detect the cars in a video. Let me bring up another video so we check it out in the video. So let's say this traffic underscore 1.mp4, traffic underscore 1.mp4. Traffic underscore 1.mp4. So if I should load this, you can see it's detecting all the cars. You can see, I don't know what car I saw here, and I don't know what car I saw here. Like I said, it is not 100% perfect, but it has a high level of accuracy. You can see how it detects all these cars that are coming. You can see how it detects. Let's try traffic 3. Traffic 3. Okay, so for this particular one, you can see how it detects all those cars. I don't know what car I saw here and here. So, and this other one's here too. So basically, that is how you detect cars in videos and images. If you have any question, please, the comment section is open. Thank you very much. Don't forget to like the video and drop your comments. You can also subscribe to the YouTube channel. So thank you very much. I'll see you in the next video. Bye for now.